Greetings physics students, and welcome to a video where I'm going to show you how to do a ray diagram for lenses, okay, specifically for a converging lens. So the ray diagram, we don't actually need to draw the lens itself. We're just going to draw a line that represents the center of the lens. So I'm using graph paper here. I would suggest graph paper for you as well. It is going to make your job easier if you have all of these nice grid lines. Also, it provides you an excellent way to do a scale drawing, because we can just make a scale, right, where the scale is 1 centimeter equals 1 square. So if we have that scale, then we don't have to measure. We can just say that it's a scale drawing, and the scale drawing is where 1 centimeter equals 1 square. So there is a scan of this graph paper posted to the assignment for you to do your own ray diagrams according to certain specifications. So you can print this out and use it to do yours. Or if you have your own graph paper, you could use your own graph paper already. But anyway, I would like you to use graph paper for this. So first thing we do is we draw a center, a line that represents the center of our lens, and we can see that nice and clearly on the video. Then we need a line for our principal axis. So we're going to just do that right here, about through the middle of the line we just drew for our center of our lens. Now we're going to take an image, and all we're going to draw for the image is an arrow that's upright. So I'm going to make it be at, say, image at 15 centimeters. Okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to just draw an image here. And the easiest kind of image to draw is just a little arrow. I drew mine 2 boxes tall. So that little arrow is our, sorry, not image. What am I thinking? It's not an image. It's an object. Object. So we're making our object be just an arrow. Imagine like a cardboard arrow or something, just sitting here, minding its own business. Okay, so it's just sitting there. We're gonna we're gonna project it through the lens here and see what we get as an image on the other side. So we're gonna say that for this one, let's just say that the focal length is 5 centimeters. So focus at 5 centimeters. So that's going to be 5 squares. 1, 2, 3, 4, 5. So this is F right here. The focus, the principal focus. Okay. Let's see if we can zoom this in just a little bit. Super high tech. And now what we need to do is mark the focus on the other side as well. So 1, 2, 3, 4, 5. There's the focus on the other side. Remember that the focus is on both sides. So the focal length is 5 centimeters. That means there's a focus on both sides of our lens at a distance of 5 centimeters. So now we're going to draw 2 of our special rays. I'm going to just do 2 instead of all 3. So we will start from, I'm going to pretend that the tip of that thing is actually on the line, even though I drew it a little bit weird and the tip is sticking up above the line. We're going to call the line actually be the tip there, so it makes it easier to draw. So we draw this ray parallel to the principal axis, and that is the special ray that will now refract through the lens, down through the focus on the other side of the lens. So that is our special ray. I think that's the first one I showed you guys in the videos about this. So here is that special ray refracting through the focus on the other side of the lens. So I need to extend that through. Then the next one we want to draw is the one that goes just straight through the center of the lens. So we're just going to do that like this. Bam, through the center of the lens. And we get an intersection right here. You know what, I'll do the third one just to show that they all do, if I do this all correctly, that they all end up intersecting at the same point on the other side. So let's get this lined up, draw this line to here, and then that will bend parallel on the other side of the lens. And there we go. This is our intersection point right here. Boom. So this is the image location. This is where we could put a screen. If we put a screen physically, like if this was a physical situation, this is an actual lens, this is an actual object, we could put like a white screen in this position and we would see an image of this thing on the screen. Okay, so right here we have the image. It is smaller than the object and it is inverted, so it's upside down. Okay, so that is how you draw a ray diagram according to certain specifications. In this case, we had our object at 15 centimeters, the focus at 5 centimeters. We drew our special rays. You do not need to do all three. You need to just do two. And yeah, pick any two that you like, draw them, find the intersection point, and then draw the image. All right, draw the image actually in there. Like that, the tip of the image should be at the intersection point, and the base of the image should be on the principal axis. Okay, we'll do one more quick. I'm going to do this one really fast. Since I already talked through the whole process, I want to talk about what ends up happening in this specific case. Okay, so I'm going to draw the lens there. I'm going to draw the principal axis. And then, that's not the greatest principal axis in the world, but whatever. I'm going to make the focal length, the focal length is going to be, we'll do 5 again. There. So there's the focus. Focus on the other side as well. So the focus at 5 centimeters. All right, and then I'm going to draw my object closer to the focus, closer to the lens than the focal length. So this object is, we're doing two squares tall, so 2 centimeters tall on our scale. All right, and it's inside the focal length. So how does this work? Well, let's draw our special rays. The first one goes here and then down through the focus on the other side. So get that lined up. I think I missed a little bit there perhaps. So there's our ray number 1. All right, I'm going to kind of draw arrows on these other ones just so we remember that these are light rays that we've drawn here. Okay. And so here we have ray number 1 for our second example. Then we have ray number 2 straight through the middle of the lens here, like this. And of course they don't intersect. So how are we going to find our image? There's no intersection of these two things. So there's no image, right? Oh, guess we're all done. No, not done. All right, so what we're going to do, this means that our image is going to be virtual. So what we have to do is line up our ruler again with the rays that we already made, and then we're going to extend this line backwards. I use dotted lines to show that this is not actually a light ray. And then this as well. Okay. And then what we have here is an intersection point right here. So if we want to see this, we would have to view it from this area over here. We'd have to look through the lens in order to see this image back here of our object. It would be a virtual image, and it would be located at this position. It is upright, virtual image, not inverted, it's upright, and bigger than the object. All right, over here on our previous example, this is a real image because light rays actually pass through this location. Here, there is no light rays passing through this location. We could not put a screen behind the lens and have this image show up on the screen, right? It's not actually there. It's just something that you can see virtually by looking through this, but it's not an actual like thing that you could put your hand there and see the image on your hand. On this one, you could actually put your hand there and you would see the light creating an image on your hand or on a screen. So it's real, it's inverted, and in this case, this is smaller than the object. But in some cases, this same setup would produce a real image that is larger than the object. It just depends exactly how you set things up. So that is how you do this. Best wishes with the activity, and thanks for watching.